Okay, so we're back. Biases and overgeneralization. So our model, despite being trained on a curated subset of the internet, still inherits many unchecked biases and associations. Many associations we've discovered appear to be benign, but yet we've discovered several cases where CLIP holds associations that could result in representational harm, such as the denigration of certain individuals or groups. And I think what they're saying here, well, they go into more depth, but I think this has to do with probably like an incomplete data set or not enough training examples that actually come from these groups that they're like saying the model's like biased toward. Anyway, now let's keep going. My hair is everywhere. Okay, we've observed, for example, a Middle East neuron, number 1895, with an association with terrorism. Oh my gosh. And an immigration neuron, 395, that responds to Latin America. Oh shit. We even have found a neuron that fires for both dark-skinned people and gorillas. No! We are there again. Mirroring earlier photo tagging incidents in other models we consider unacceptable. Ah! These associations present obvious challenges to applications of such powerful visual systems. Whether fine-tuned or used zero-shot, it is likely that these biases and associations will remain in the system, with their effects manifesting in both visible and nearly invisible ways during deployment. Many biased behaviors may be difficult to anticipate a priori, making their measurement and correction difficult. But we believe these tools of interpretability may aid practitioners the ability to preempt potential problems by discovering some of these associations and ambiguities ahead of time. Our own understanding of CLIP is still evolving, and we are determining if and how we would release large versions of CLIP. We hope that further community exploration of the released versions, as well as these tools we are announcing today, will help advance general understanding of multimodal systems, as well as inform our own decision making. The conclusion: alongside the publication of multimodal neurons and artificial networks, we are also releasing some of the tools we have ourselves used to understand CLIP. The OpenAI microscope catalog has been updated with feature visualizations, dataset examples, and text feature visualizations for every neuron in CLIP ResNet 50x4. We're also releasing the weights of that same model and a smaller model to further accommodate such research. We believe these investigations of CLIP only scratch the surface in understanding CLIP's behavior, and we invite the research community to join in improving our understanding of CLIP and models like it. Okay, this is really cool. So the authors of this paper are Gabriel Go, Vanessa Voss, Daniela Amade, Shan Carter, Michael Petrov, Justin J. Wang, Nick Camrata, and Chris Ola. And they give some acknowledgments to Santini Argwal, Greg Brockman, Miles Brundage, Jeff Clune, Steve Dowling, Jonathan Gordon, Gretchen Kruger, Faiz Mandviwali, Vendant. Okay, yeah, I'm gonna continue murdering these names, but this is cool. This is really cool, and there's like 23 papers listed under the reference section. I wonder if any of these are recent. It looks like there's a paper called Invariant Visual Representation by Single Neurons in the Human Brain, Deep Residual Learning for Image Recognition, Visual Higher Learning Layer Features of a Deep Network, 2009. Intriguing Properties of Neural Networks, 2013. Understanding Deep Image Representations by Inverting Them, 2014. Deep Neural Networks Are Easily Fooled, High Confidence Predictions for Unrecognizable Images, 2015. Okay, there's something from 2017. Plug and Play Generative Networks, Conditional Iterative Generation of Images in Latent Space. Oh, this one's kind of cool. So it's from 2021. It's called I think that this is literally this one. Multimodal neurons in artificial neural networks, but it's on Distill. I wonder if this is the exact same paper. Is it? Oh, it's not. Oh, okay. It goes... Okay, this one actually goes a bit more in depth. This is kind of cool. It's basically the same thing. Okay, but there's like a bit more. Oh, there's way more references in here. Oh, this is actually useful to understand. Okay, so I'm gonna have to deep dig into this one, but it's on the Disto website, and it's called Multimodal Neurons in Artificial Neural Networks. Yeah, it's basically the same. It's like the same publication with a few more examples. So, well, that was it. Got through the whole paper. Oh no, that's interesting. It's basically what they've been trying to do for a while, which is understand each neuron specifically, like in an artificial neural network, and understand like what that particular neuron understands in relation to the whole like deep neural network or model, right? And that's useful because if you realize like you have 3 neurons that are like that understand, I don't know, cats, and you're like actually trying to train like a dog model or something. Maybe that's an awful example. What's more useful? Okay, so like the example that they actually gave where they were like, they were talking about biases, and then they said we got some negative affiliations between like immigrants and like Latin Americans, and or something about like Latin America, and that they had this like old correlation between like blacks and gorillas. That's one that's happened before, and it's just because there wasn't enough training data of like black people doing normal shit, which is like weird, right? Because there's like a ton of black people. Like, how do you actually not have your training data of black people doing normal shit? But I mean, it could happen, right? Because like, I guess before Instagram, or even now, right, there's just not that many people who are doing maybe normal type stuff, and we need more diversity in spaces that are not like just traditionally black, which is why I'm out here making content. So that's all for today, guys. Peace.